Hey everyone, happy Monday. We'll just give everyone a couple minutes to trickle in here and then we'll start with the demo day and hand it over to Nathan and Kelly. All right, hello everyone, happy Monday. Just a couple of quick things before we start our demo day, really just for scheduling and whatnot. So this week we're in week 22, if you can believe it. So we have this week with Nathan as your instructor and Kelly as your teaching assistant. So we have this week. Next week you'll be with Anissa learning the fundamentals of cybersecurity. And then the last week of class is just dedicated for Capstone help and assistance. So only really 2 more weeks, including just a teaching time, and then I'll just be helping your capstones. Last week I sent out a rundown of how the last week will look. If you have any questions on that, I'll bring this up again next week as well, but week 24 is going to be here before you know it. So if you have any questions on that, hopefully you've had an opportunity to review kind of what that looks like for the final week. If you have any questions, again, please let me know. I'll have a reminder next week as well. But we're getting close, guys. We're getting really close to the finish line. So hopefully you're starting to feel excited. Hopefully no one's freaking out too much. If you are, that's okay. You'll have plenty of help and support, on that final week of class. But, based on what we're seeing in everyone's capstone so far, I think everyone's in pretty good shape. So without further ado, as always, we've done this hopefully a million times by now. And I know sometimes these can kind of be a drag for these demo days, but by graduation, hopefully you'll, kind of see that it'll be very similar to your capstone presentations. It'll just be a little longer format for your capstones. So without further ado, go around the room, share your updates in your capstone. This morning, Nathan shared a list of folks that have deployed their projects, and it was awesome to see many of you have deployed, which is great. So feel free to share that if you'd like, or where you're at. So without further ado, and as always, I'll share the peer reviews and the submissions in the chat. We'll go ahead and get kicked off for any capstone updates you might have. So why don't we go ahead and kick off? Ariel, if you'd like to give an update on your capstone project.
Hi, so I have done Cypress and started my front end this week into switching them over, but I did want to share my screen if possible, just to kind of show where I've actually come at this point. So we have, most of the site is up now with the features. Like I said, I put Cypress in it. had to spend more time on JavaScript than I anticipated. It is static. So that's my biggest part right now, is just switching it back over to a back end as well and then deploying. That's my biggest goal for this week.
Very good. Thanks, Ariel. Appreciate it. All right, next up, Brandy, you want to give an update for your project?
Yep. So nothing pretty. I will share my screen though. I'm finishing up a few styles with React, and I started my backend again.
Can't see your screen just yet if we're trying to. No, we can see it.
Nothing pretty. There's the carousels work now. I have a contact page, just fixing the styles and getting my backend fired up is where I'm at.
Excellent. Thank you, Brandy. Appreciate it. All right, next up, Brielle, if you want to give an update on your Capstone.
So it's coming along. I have everything built out that I want in terms of the front end. I'm having some compiling errors I'm working through with hooking it up to the database and pulling things, but I'm working on it. But altogether, it's getting close, so I'm very excited.
Excellent. Thanks, Brielle. Appreciate you sharing. Next up, Carolyn, if there's anything you'd like to share for today.
Thanks for asking. No, I'm deep into research on other apps because this is a more involved topic than I thought in terms of legal things and everything. So before I do any more coding, I want to make sure I really know what I'm doing in that arena. But thanks for asking.
Awesome. Thanks, Carolyn. All right, next up, Dominique, if you want to give an update on your Capstone.
Sure. Let me see if I can show my screen. All right, so pretty much I moved everything over to Heroku. Finally did my back end. And my site is a lot faster than I thought it was going to be, which is really, really good. Now everything's popping up pretty fast. Let's see. Like everything is like really, really fast. So right now, all I'm doing is just adding information, making sure all my buttons are working, which they seem to be doing. And that's pretty much where I'm at right now.
Excellent. Very good. Thanks, Dominique. All right. Next up, Phobilia, if you'd like to share anything, if you'd like.
Oh, sure. Right now, I have a fully functioning front end. I did the first deploy yesterday, and everything is working fine. I've made a list of the things that I need to add. Like I need to add the about section and still a contact page. But so far, so good.
Very good. Thanks, Phobilia. All right. Next up, let's see, Karen. I don't think she's present today. Next up, Jahil. Not sure if I saw Jahil in the chat, so I'll circle back at the end if he's able to join. So that means next up, Kyle, if you'd like to give an update.
Sure. So where I'm at, I've got everything into React. Google Maps is working in React. I'm working on fixing the pop-up windows on the map to display only when the marker is clicked. Right now, I've just got them coming up when the page loads. I'm fixing the display of directions. I haven't quite got that working yet. The audio is hooked up to the play button in the navigation bar. I'm working on getting the other audio controls hooked up and selecting which audio it's controlling. I need to write the code for the geolocation, which I'm only going to do for the direction starting point. I've decided to save the automatic play of narration for an extra thing if I can get it done like the last week or something, or maybe after the program. My backend is complete. I am working on loading the data into the database and connecting that to the front end. I'm still working with dummy data on the front end, I mean. And I need to fix my API key so that it's hidden. But I am going to share my screen to show my map. Hold on. That my map is actually working because the deployed version just has a screenshot. So I do have markers on there, and I have eventually it's going to have directions when you click the button, but I haven't quite got that working yet. So that's where I'm at.
Very good. Thank you, Kyle. One thing really quick, I wanted to point out something Kyle mentioned. You know, if you feel as though, you know, you need to cut scope, now is the time to do it, right? So, you know, if there's something kind of like the nice to haves, right? So get your app working as best you can with the necessary stuff, everything that's kind of like the bonus or, you know, the pluses, if you will. You know, don't feel bad if you don't get them done by graduation. That's always something you can work on afterwards. Just kind of keep in mind, you know, MVP, minimum viable product. How do I get this thing out the door for graduation? So just want to point that out from something that Kyle just mentioned. All right, next up, Latanya, if you'd like to give an update.
Yes, please. Can you all see my screen?
Yes.
Okay. So this is my deployed site. This is the home page. And I just thought I'd just give you all the tour. So this is the top. It goes down. You see my body links. These all work. Go down. I'm hoping to be able to add in my API. If I do, I'll have the temperature for Albany, New York, and San Jose, Costa Rica down here as like a little added. And then I just wanted to show, this is not wired up yet, but this would be for favoriting this video. This is all set up with Gumroad, so you can actually go in and buy the items if you wanted to. Check out. The search works. I decided not to use a submit button because it just pulls it up. See, it wasn't going this slow before, but it just works on its own. So that's that. And then when you click this button, it takes you to the back front end. If it goes, my internet is super slow. Which is also deployed, both the homepage, the back front end, and the back is they're all deployed. So this is what that would take you to if it went through. So this is the back front page where they would either log into their current account or sign up for a new account. So if you went into an account you already had, you would have this dashboard. And if not, it would take you to create account. Oh, I'm sorry, I don't have the, I forgot to make that run. But that's pretty much it. I have everything in. I just need to wire stuff up at this point, and hopefully I can get the API attached in there as well. So that's where I'm at.
Awesome. Thanks, Latanya.
Yep.
All right. And one other quick thing. I know I'm kind of going ad hoc, just calling a couple of things out here I'm noticing. But Latanya kind of brought up as well where, you know, she kind of showed her localhost. If you're having problems with your deployment, you know, ideally in a perfect world, if you get everything deployed and, you know, successful and people can go on your app by the 26th, awesome. If not, like it's totally fine to demo your localhost too. So I was going to throw it out there. You know, if you're on the final stretch and you just can't get something deployed, you know, for whatever reason, that's totally fine. Just want to call it out too. All right, next up, Mel, if you'd like to give an update on your Capstone.
All right, can you hear me?
Yep, we can hear you.
Sure. All right, can you see my screen? Yeah, so I don't really have an update on my Capstone. It's pretty much is the same as last time. I've been trying a lot of things on the back end, but I haven't been having a lot of success with it. So I'm at a point right now where I kind of know exactly what I want to do, and I just kind of need to just seek some mentorship at this point. Just you know, integrating the APIs with the database and trying to figure out everything. So this is the that was a login screen. This is going to be the main page, and site looks the same right now. So just having a problem just, you know, integrating the APIs right now. So I'll get help with that, and that's all I have right now.
Very good. Thanks, Mel.
All right.
All right, next up, Sarah. I don't think I saw Sarah in the chat, so I'll circle back with her in just a minute here. So next up, Shaw, if you want to give an update.
Yeah, sure. Hi, everyone. So I deployed my front end and back end. I had some issues with my images not displayed properly, and also some debugging with the back end. Otherwise, it works perfectly. I was able to set up the email with all the fields like from, to, phone, subject, and the body of the email. So it works fine. That's all. Thank you.
Very good. Thanks, Shaw. Appreciate it. All right, and last up here, Susan, if you'd like to give an update.
Yep. Sorry. I can share my screen or not. I started the database and my backend server. I have my festival data in there, but I don't have it connected properly with my location. And what I was worried about has happened is that like the images for all the festivals are doing wonky things to my cards. So I have to figure that out. So basically just, I need to sort locations and festivals correctly, then make sure the images are right. And then after that, get my search working. And then after that, it doesn't look right on mobile. So I'm going to attempt that. And also I never really went over all the accessibility stuff. So I do want to do like a run through to make sure that's, I've gotten that covered as well. So that's my short list.
Awesome. Thanks, Susan. And one other thing as well that Susan brought up, if anyone would like a review of their capstones, if you will, like from what it's looked like when it's deployed to localhost to even like a code review, like I'm happy to do that. So just feel free to send me along a note and I'd be happy to review anything you like. Just checking, see if Jahil or Sarah joined. I don't think we have either one of them. So that concludes our demo day, everyone. As always, carve out some time for any questions, thoughts, feedback. I guess what I'll say is two things. One, it's awesome to hear how far along many of you are. It's just great to hear things like my backend is deployed or my front end is done. So that's really, really awesome. And you guys still have time, to put those finishing touches on. So certainly if you need help, don't hesitate to reach out. We have plenty of instructors and TAs that are happy to carve out one-on-one time. Whatever you need to get over that finish line. But I'm really great to see everyone's at. I'm consistently and constantly impressed by all your progress for those 24 weeks. And I think that Capstone project really is the encapsulation of all that. So really nice work, everyone. And one other quick note, I'm not sure, Nathan, if you went over this last week or plan to carve any time this week for it. I know a lot of projects that were just demoed. Some of you had custom domains, but I noticed a lot still have the herokuapps.com. I'd be happy to go over like a little offline video of something of like how to actually like host that on like on a domain properly. I'm not sure, Nathan, if that's something at all that was discussed or folks would be interested in that, but if I'd be happy to do that if folks might be interested in that. So that's a point that I was kind of like a question, I guess, to you, Nathan, and then the rest of the class, if that's something.
Yeah, we talked about how to set the DNS record to point from Namecheap to Heroku.
Very good. Okay, then I'll shut up then. Very good. Any questions, thoughts, feedback from anyone at all? Going once. Going twice. All right, everyone. Great work as always. And again, if you need any assistance at all in your capstones, please don't hesitate to reach out for help. We're all here to get you through the finish line. So let us know whatever we can do to get you there. And with that, I'll hand it over to Nathan and Kelly here. Thanks, everyone.
Thank you.
Have a great night.
See you, Jesse. All right. Welcome to module 11. So we're going to be talking about cryptography tonight. Before we get started, I would like to introduce Kelly. Kelly, would you like to say a couple things?
Sure, I can take a second to introduce myself. So my name's Kelly, as you can see on the Zoom screen. I was here in May for 2 weeks with Ryan, TAing the HTTP module, and I'm excited to be back again for cryptography, mostly because it's a bit of an interest of mine. So I'm excited to be here while you all learn about this topic that I am super interested in. And let's see, is there anything else I really want to mention about myself? The other thing I'd like to say is that there's so much growth between like seeing your capstone presentations in May and seeing what everyone presented tonight. So I just wanted to take a second to say congratulations. It's clear everybody's been making progress, and that's really cool to see. So I look forward to watching all of your capstone presentations at graduation.
Cool. All right, I got slides. I got slides for tonight, and assuming my computer doesn't crash. Okay, still here. Awesome. Let me grab those. I'm going to go paste them into the students chat if anyone would like to follow along. Okay. So just a quick reminder for the homework. Last week, we were talking about DevOps, and I posted 2 assignments. One was for sending me a link to your front end. As Jesse mentioned, I compiled that into a list, which is awesome because it kind of shows that, you know, folks are getting to that point where their apps are deployed and we're on track for doing that demo. So that was one of the homeworks from last week. Don't forget to throw that in. I know the cutoff is midnight at Sunday, but just try to get it early in that assignment early in this week, and that'll be fine too. Also, if you have a backend, there's another assignment. So for the folks that don't have backends, you can just safely ignore that. Or better yet, if you just leave me a comment saying I'm not doing a backend on that homework, that would be really helpful. But if you've got a backend, make sure to send me a link to that as well. Just need a link. I don't need a link to your GitHub or anything. Just send me a link to an API endpoint that your backend exposes, and that'll be more than sufficient. For the rest of this week, every homework assignment is going to be related to your capstone. So for any of the homework assignments this week, please send me Heroku links. Send me links to your GitHub repo. So when you get done doing whatever the homework is or whatever, please make sure to commit, push, shove it up on GitHub, and send me those links. I think at this point, we've kind of all been working in that workflow anyways. So if we can move our homework over to GitHub, that would be awesome for me. But I'll leave all those instructions on the homeworks as we post them, just giving you that as just a general announcement. Okay, so let me share my screen and we'll get started. All right. So this week we're going to talk about cryptography, and cryptography is kind of a big beast. There's a lot to it. There's a lot to unpack. And as I was preparing for this, far before the classes started, I got off on some rabbit trails. I mean, there's so much stuff to talk about cryptography, and you know, I had set up some games and crypto quotes, and I don't know if you folks have seen in the newspaper how they have those crypto quotes where, you know, you try to guess what the scramble is. Has anybody ever seen a crypto quote in a newspaper? So some people have. So it's like a scrambled message, and you're supposed to come up with what the cipher is. You're supposed to decode it. Well, anyways, I scrapped all of that. What we're going to do this week is we're going to get down to the nuts and bolts of what we need to know in order to securely deploy our software, to feel comfortable with our customers visiting our website, potentially giving us sensitive data such as their email and potentially their password. All right, so cryptography, the definition. The definition of cryptography is the practice and study of techniques for secure communication in the presence of adversarial behavior. What do people think adversarial behavior means? Adversaries. Yep. People that are out to get you, people that want to steal the data that your website is collecting, people that want to do your website harm. They're your adversaries. They're the people that we use cryptography to prevent against. And next week, I know there's going to be more talk about specifically how to harden your app, how to make it more secure. But for cryptography, we're primarily focused on setting up that foundation, setting up the safeguards that will prevent adversaries from coming in and doing something malicious with our website or doing something unintended. And actually, before I jump to that, you'll notice that the first thing that this calls out is secure communication. So securely talking to our website. So when we dive in a little bit deeper and we talk about each of the different parts that compose cryptography, the first and foremost topic we're going to get into is communicating with our customers securely. Because if we can't talk securely with our customers, then our customers can't trust us with data. So if everybody is able to see what our customers are doing on our website, then that's not going to foster much trust. And if we don't have that trust established, they're not going to want to buy things from us or trust us as professionals. So cryptography is focused on communicating securely. But we're also going to touch on some other things that I mentioned last week, such as authentication and authorization. So when users come to your website, how do you know who that user is? So we're going to talk a little bit about verifying who the customer is, who the person that's visiting our website is. And then once we've verified who that user is, we're going to talk about restrictions. So take, for example, Latonia's app. Latonia has different personas. She has folks that just visit the website, can browse and shop around. Then she has people that have bought things, and then they get their own panel. And then they can log into that panel and they can view their past purchases. So this idea of your website having different roles and different permissions for what users can and can't do, we're going to talk about that as well. And then lastly, I'm going to do my best to convince all of you that this is a bad idea. But lastly, we're going to talk about potentially storing some sensitive data. I know a few of you are attached to the idea of storing passwords, and I'm going to do my darndest to convince you otherwise. But if we have time and I haven't done a good enough sales pitch, then I'll show you. I'd rather show you than you guys not know and then potentially shoot yourself in the foot. So we might store some sensitive data. We're gonna use the we're gonna use the proper cryptographical terminology for each of these topics. So when we talk about communicating with our customers securely, we're going to refer to that as securing our communications. And then as far as verifying who the customer is, that's known as authentication. What they can do in our app, authorization. And then encryption is involved in terms of storing sensitive data. So those are our terms. Oops. According to Google, if you do not follow what I teach you this week, a nasty shadowy figure that wears a hoodie and wields a silver laptop will come out and steal all of your data. They always wear hoodies, and for some reason they look like the same guy. Okay, so tonight we're digging into securing communications. So there's two things that we have all been using all class class long since May, and that's HTTP and DNS. Does anybody, pop quiz, does anybody remember what HTTP stands for? No Googling. I'll know if you Google. Hypertext Terminal Protocol. Close. Close. Transfer Protocol. Yep.
Secure, right? For HTTPS.
Ooh, you're ready to dig into the next slides. So HTTP is what we've been using. When you think about how you run npm start, it always binds to localhost 3000, and then you go and visit in your browser with HTTP localhost 3000. So you've been using HTTP all class long. Same for DNS. We haven't really talked a whole lot about DNS, but we'll talk about that tonight. So first, let's dig into HTTP. This is one of the most important things we need to look at when we're securing our communications. So again, HTTP is what we've been using since we last saw Kelly when we were talking about different methods for HTTP, like get, post, put, all of that. HTTP is, if you're thinking of how the communication on the internet works, HTTP is kind of the highest level. It's the thing that we interact with the most as developers. And it comes with a message body with some HTTP methods. It has a response status code, all of that sort of thing. And then just here are some examples. You've seen this in your code, but all of these examples right here are using HTTP. As Brielle was pointing out, though, we should talk about HTTPS and what the difference between HTTP and HTTPS is. It used to be, what, like 3-4 years ago, that browsers by default showed a green lock when you went to visit HTTPS in the URL bar. Nowadays, HTTPS is so ubiquitous that you see a squiggly through the lock if you're not using HTTPS. HTTPS is kind of the standard now for websites. And then if we look at these examples again, you can kind of tell which ones are using HTTPS and which ones are using HTTP. Just tack it on the S at the end of it. So what is the difference between the two? Well, it's probably what you guys have already guessed. HTTP is the unencrypted protocol. It's the unencrypted version of all of your HTTP requests, all of those things that you've been practicing. And HTTPS is just the encrypted version of that. But let's get a little bit into the terminology because it kind of gets thrown around a lot. When we say HTTPS, what we're really meaning is it's HTTP under the hood, but it has this encryption bolted onto it. So there's no, let's say you're using Axios. With Axios, you don't change how you're doing gets, you don't change the headers that you're sending, you don't change, the call to the module Axios is the same regardless of HTTP or HTTPS. The only thing that's changing is the URL. And so HTTPS is really HTTP at its core, plus this encryption layer added on. And when we say encryption, what we really mean is that it's HTTP plus TLS or SSL. And TLS stands for Transport Layer Security. And it's not something that I can easily explain. We'll kind of have to go into it from a intuitive perspective. But when you hear the word TLS and you hear the word SSL, I want you to think of those things as being synonymous. The historical background there is that SSL came out first and TLS replaced it, or I guess I should say it superseded it. No, superseded isn't the right word. It came after SSL. So some folks will say SSL when they're talking about HTTPS. They're not wrong. It's still the same concept under the hood, but nowadays the specification that's moving forward, the thing that we're actually using in modern browsers is TLS. All right, that's kind of all of the talking at you, I'm going to do for this first part. Any questions so far? Okay, let's look at an example. So here's my crudely drawn person, stick figure. That's us. And we're sitting at our house with our MacBook. That's a MacBook, believe it or not. This is the router that everyone has in their homes. And then here is your ISP of choice, whether that's Comcast or CenturyLink or Charter or Verizon or whatever. And then over here is whatever the resource it is that you're trying to access. So Google.com, Facebook, your Roku app, whatever. So let's look at the way HTTP works. So let's say that we're logging into a website. So it starts off from our computer, we're initiating an HTTP request. So we initiate the request, it gets sent to the router. The router, all its job is to facilitate forwarding those network requests onto whatever the next thing is. It goes to the ISP. The ISP does its forwarding, and eventually it lands at whatever the server is. And the server will send whatever the response is. So let's just say that they returned 200. So the login was successful. So that gets returned all the way back to us. So if we are making a post to a login endpoint and we're trying to log into a website, we just got a 200. Life is good. So that's HTTP. The problem with HTTP is that it's unencrypted. So anywhere between you and that Google or that Facebook or whatever website it is that you're trying to reach, anywhere along there, anyone can see what you're doing. Anyone can see the contents, anyone can see what the website is. Because it's unencrypted, everyone can see it. Now, contrast that with HTTPS. So with HTTPS, I'm not going to dig into the super raw details here, but before a connection is even, before the HTTP request even begins. With HTTPS, both you and whatever the server it is that you're trying to talk to negotiate a shared code, so a private code that only you and that website know. And with that channel set up, with that private shared code set up between you and whatever the destination is, HTTP requests can flow through. So all HTTPS is doing is it's securing and encrypting that channel before the HTTP request even begins. And then HTTP flows through that channel. So it's still the same HTTP at the end of the day. The only thing that HTTPS is doing is it's setting up this encrypted channel between you and the end so that nobody can peek into what's going on. All right. So I'm going to show you how this actually works. And what I'm going to do is looking at that diagram where it's us and then the router and then the ISP and then whatever the server is, Google. What I'm going to do is I'm going to create a middleman. So I'm going to create something that sits between me and the router. And this is to emulate what would happen if someone was listening in on this traffic. And I'm going to show you what happens when we make an HTTP request and what happens when we make an HTTPS request and what that looks like if we were to be a quote unquote hacker, if we were to try to man in the middle between these two things, what we would be able to find. Okay. But before I begin, I know this isn't the DevOps module, but I'm going to give you a free terminal command that I find really useful. So if I open up iTerm, if you ever want to inspect all of the data flowing through your Mac's network card, you can say sudo TCP dump -a, and it will require you to enter in a password. That will show you all the data that's currently flowing through your network card. And this is what I'm going to use to show what the difference between HTTP and HTTPS. And it's going crazy right now because I'm on Zoom and it's showing all of the traffic that my Mac is sending through Zoom. So I'll go ahead and cancel that. Okay. So let me set up this. Let me set up this man in the middle here. Okay, so all this is going to do is it's going to listen to all the traffic coming out of my MacBook that's destined or is going to this website. So any network requests that are made to my secret login service will be captured by this, the man in the middle. Okay. So we'll leave that up over here. And then in another terminal, this is going to represent the browser. So let's pretend like we're logging in. Kelly, you guys used curl in your module, right?
We did. We did use
Awesome.
Decrypt.
Okay. So we're going to use curl here as well. So this is going to be the, let's pretend this is the browser. And we are at Nathan's, not backend store. Here we go. I'll update these on the slides. Let me clear my screen just to make this real clear. Here we go. Okay, so we're going to log in to the secret login service on Heroku, and we're sending it some JSON. We're sending what our password is, and in this case, the password is my password. So we're logging in. I hit enter. This is why we all want to use the hobby tier on Heroku, so our apps don't take 7 seconds to spin up. I think TCP dump is just, oh, here we go. There we go. Sorry about that. I think TCP dump is getting lagged behind because there's just so much stuff getting shoved over the video connection. Okay, so I made a request to this login service, and here's some of the traffic that my network card recorded. And you can see right here that because I'm using HTTP, anyone can see that I'm making a network request to secret-login service at Heroku app, and anyone can actually see the contents of the password that's being sent across the wire. So this is just plain HTTP. Okay. So not good, right? Another example, if you're at a coffee shop and you did a login like this, everybody at the coffee shop that was listening to traffic being forwarded through the router would be able to see your password. Or airport, wherever you are. Okay, let's switch this to, I'm going to just make a new terminal so we can get rid of that. All right. So now we're listening on the network card. I'm going to do another login, but this time I'm going to use HTTPS. So same result, we were able to log into this service successfully, but the data is different. So what folks are able to see, my computer transmitting down the wire looks like complete garbage. And that's because it's encrypted. So if we were to search in here for my password, hit enter, it's not there. It's because HTTPS is encrypting this for us. In fact, we can scroll up to where so here is the only thing that folks would be able to see, and that is the host name. So people will be able to still tell where it is you're sending a request to, but not the contents of the request.
Excuse me, Nathan.
Mm-hmm.
This is Latonia. So is this all like just junk code? Like, is there a way to parse through this code and understand any of it other than knowing that you went to that particular site? And is that intentional? Or I'm just trying to figure out if you can actually do anything with any of this other content that's in here. And then is there a layer of HTTPS that would make it so they couldn't see that you went there? Like, just kind of get rid of all of the info that's in there?
Yeah, that's a good question. So let me start with the first one. The other stuff that's happening in here, this is all the other requests that are being made. I don't know why there's all these additional. So actually I do. So notice here, there's the Starfield Services root certificate. So we're actually loading some data about the certificate that's being used on this website. I'm not really sure what the rest of this data is other than requesting the data needed to encrypt this channel. So if we switch back to HTTPS, or sorry, we switch back to HTTP, clear this, and rebind. So a lot of these calls are going towards EC2. Oh, because Heroku is hosted on EC2. So this is getting redirected through EC2 as well. And I think this is what all of those different jumps are, is the redirects through EC2, because Heroku is really just EC2. But all we really care about is this message right here. That's the actual request we're making being returned. But this is TCP dump. This is the raw output from your network card. So don't feel like you have to come in here and memorize this. This is just a useful tool for inspecting the traffic flowing out of your laptop. And as far as if you wanted to hide what the actual host is that you're visiting, that's probably where you'd want to go VPN. I think DNSSEC, which we're about to talk in a second, I think DNSSEC might help with this, but we'll test that here in a second. Good questions. Other questions?
There's a question in the chat. Mel asked if there's a way to get past the encryption.
There is. If you're the website that this is targeting. So if you control the website that your customer is visiting, you can, the encryption is there for your benefit. And by having that HTTPS website set up, you, the person that owns that website that the customer is trying to visit, you are able to decrypt the data. But for other folks to be able to beat that encryption, no, I don't think so. Not until you get into like the quantum computer kind of stuff. Don't quote me on that. Maybe that's a good Anissa question for next week, but I don't know what the brute force complexity of beating TLS is, but I'll tell you, it's good. If it's good enough for Amazon.com to use, then it's sure good enough for me. Any other questions?
So this is Latonia. I'm kind of piggybacking off of Mel's question. I'm just wondering how hackers get into these sites the water supplier. I can't remember what it was, but I'm just curious how there must be some way. Do you have to get a password directly to be able to do that? And I don't even know what a quantum, what you just said is, and how it's even possible.
I'll tell you that some of the stuff that you see in the news about hacks are not hackers finding a way to break the TLS specification or finding a way to circumnavigate HTTPS. Most of the stuff that you see, honestly, isn't really related to HTTP security at all. It's more related to, we left a printer driver attached on port 9000 that's using an old version of Microsoft Windows that hasn't been patched in 10 years. Like a lot of the government sort of stuff is, they don't have the budget to buy the latest and the greatest, and they're probably not running on the cloud, so they're the ones that get kind of crushed. But there are a lot of ways to shoot yourself in the foot. I'm just going to rely on Nisa next week to tell you all of those. I'm just going to show you how to do the best that you can to secure your website, coming from a person that has had to do this multiple times at work for different projects. So, other questions? These are good questions.
There's another question in the chat. Jahil asked, can a third party like your domain provider decrypt your HTTPS?
That's a good, so yes, technically yes. So I don't want to scare anybody because that's not my intention here, but when you go to Namecheap and you let them generate the SSL certificate for you, or like what we did with Heroku, we let Heroku automatically generate the HTTPS, the TLS certificate that goes with our HTTPS. When you let a third party manage your certificate, then yes, you're giving them control over the ability to decrypt that data, which isn't a bad thing, because isn't always a bad thing, because what the trade-off there is if you buy it from someone else, then they're most likely going to automatically manage the renewal of that certificate, the renewal of your TLS, SSL, HTTPS. They're going to manage the renewal of it, and they'll also manage the decryption for you. So when users hit your website, whoever's providing the encryption for you will also provide the decryption. So when they hit your website, you're getting HTTP coming into your website. So you don't even have to think about HTTPS, because whoever you bought your certificate from is doing what's known as the termination. They're terminating HTTPS coming into your app and just giving you HTTP. And all that is just handled for you. That's the nice thing about letting some of these services automatically set up HTTPS for you. The downside again to that is that, yeah, you are technically giving them the ability to decrypt that data. So if you really care about who can decrypt your HTTPS traffic, that's hold tight, because I'm going to get into that. I don't know. Just because HTTPS, I don't know, because HTTPS isn't the same protocol that email uses. Email uses what, like SMTP. It uses its own kind of protocols, and some of those have TLS. So most of the popular email providers will encrypt your email for you. SMTP, that's it. Yep. In fact, I think SMTP is baked in with SSL. You can't run an unencrypted version of SMTP. Okay, other questions? We're actually overdue for a break. So how about we take a quick 10-minute break, and then we'll come on and talk more. So 6:36. All right, see you guys in 10 minutes. Kelly, Kelly, they're giving me the hard questions. Help.
Oh man, I have to say, I'm really impressed with the questions so far. All of these have been so good. They're really thinking about it. People are throwing out answers in the chat. I'm like, I don't know if I can say HE double hockey sticks on the YouTube stream and get in trouble. So I'll just say, heck yeah. Some really good questions going on.
Well, it must be satisfying for you having been there earlier on and then seeing the progression at this point.
Oh my gosh, it feels so good, dude, to be like, wow, people are really learning stuff. They're interested in the material. Like everybody's really come a long way since May, which is rad. Good job. How have your modules been so far?
Oh, good. I learned a lot. This is the first time that I've prepped this material, so learned a lot of stuff that works, some stuff that doesn't. This is the best that you're going to see me. This is week 3 out of 3 for me, so this is the best that. Brady, that's an excellent question. How does cross-origin resource sharing play into this? Technically, it doesn't. Regardless of HTTP or HTTPS, it doesn't. But CORS is important in terms of just security in general because it prevents websites, or it prevents requests coming from websites that you don't want accessing resources. I think that you guys have been just enabling CORS for everything. Does that sound right, Brandy?
I don't know.
Yeah, you just install the Express CORS middleware, and that's it, right?
Yeah.
Yeah. So what that does is, by default, it allows anyone to make a request or anyone to load JavaScript and make requests to your API server, which isn't a bad thing when you're developing, but is definitely one of those things that you would want to lock down for your production website. Also, another really good question to bring up next week, because I'm sure Anissa is going to talk about that. Yep. Latonia, when you say OAuth, is there an operating agreement?
Oh, I thought that's supposed to be oath.
Oath. Okay. Sorry.
No, I know
It's
you
Monday.
have tech brain. That's called tech brain.
It's Monday. The reason why is because there's a terminology that we're about to talk about. Maybe today, probably tomorrow. It's called OAuth. It's a
Oh, okay.
specification. So I saw that and I was like, oh, are you trying to jump ahead or are you thinking ahead or something?
No, I'm
And
not.
is there, I don't know.
Okay.
I don't really know. And honestly, I haven't really thought about it too much because I haven't really thought about it too much. And it kind of bugs me now that I haven't, because if you take the easy route and you let someone else do it for you, you're opening up that. And I've never gone to look to see if there's a clause in like a privacy statement or something like that.
Because their liability would be too much. So there has to be something. But I just thought I'd ask. Okay.
And I mean, those, so let's take Namecheap, for example. Namecheap sells SSL. Like, I think it's, you pay like $9, $8 or something for the domain, and then they try to sell you on like $20 for SSL. So they're selling certificates left and right all day long. And all I can think is that a website like that, they would need to take that security pretty seriously, because if anybody got access to that, to the key that unlocks that HTTPS that could decrypt, they would be out of business. Like,
so there has to be something in place. Yeah. All right. Yeah. No problem. I asked that other question about the gobbledygook. It looked like gobbledygook to me, because Gus actually showed us a trick, how he took Lady Gaga's face and made it go around. So like we were in her Twitter code and there was like a lot of like junk code in there. And he was saying like they do that to kind of throw people off of like what's what in there. But he still figured out how to get to, what he wanted and like made it spin and all this other stuff. So I was just wondering if that was like a tactic.
No, not in our stuff. The gobbledygook in our case is encrypted. So there ain't this isn't like simple obfuscation where it's like, no, we replaced the variable total with the word A. This is like, you can't decrypt it.
Cool, thanks.
That earlier question about what would be, so I think TLS certificates are generated with RSA 256. So the question is, how hard is it to brute force RSA 256? So the time taken to perform this attack measured in years is 2,117.8 trillion years. Because you would need to try 2 to the 255th power keys. And the thing is that after you spend 2,117.8 trillion years, all you've done is you've cracked the SSL certificate for one website. That's not even cracking all of them. That's just one of them. Yeah, that's a good question. I don't know what they measured that on, if that was on like a Pentium 4 or if that's on a high performance. No, they measured that off of a supercomputer, something that can perform 93 petaflops a second. That's faster than my computer.
Hey Nathan, this is Shah. I have a question about the encryption. So the emails, about the email services. So the email services encrypts your email. I mean, let's say, assume that it encrypts or will enable encryption. So it encrypts from one end to the other end. Like you send something, like in my case, I was looking at in my code, it was JSON. So it gets the data in JSON, encrypt it and send it all the way. And then the the endpoint takes that and has to decrypt it and convert it into plain text or some other data so that the browser, whatever is it, so it reads. So like you said, it's almost impossible with the existing technology to decrypt that one while in transmission. So whatever is happening due to human errors, or you share a password, other stuffs, or maybe how about the two ends? Is there something where you can hijack the data and pretend to be the receiving end and
Yes. Oh, yes. That's what we're about to talk about next. Yes.
Okay.
Yes, absolutely. Yeah, we'll talk about that in a second. That's a really good point. Yeah, since you can't defeat it in transit, can you defeat it by replacing what the destination is? And yeah, we'll talk about that. And Shaw, you got me curious, so I went and looked up my email provider and what SSL TLS they use. So my email provider requires all of their endpoints use SSL or TLS, which again is synonymous. They mean the same thing. But for both the IMAP, the POP, and the SMTP, for my email provider, all three of them require TLS encryption. And I don't know what Gmail uses under the hood, but I'd be surprised if they weren't doing TLS for you.
Thanks.
Kelly, are we back?
Yes, we are definitely back.
Okay, cool. All right, let me share my screen. Keep going. Okie dokie. So here's where I'm going to do a little bit of hand waving, and I'm going to throw some terminology out there. There's not going to be a pop quiz where I ask you to recite all of the things that I tell you, but I do just want to, I don't want to go too deep, but I also don't want to skip past some of the internals of what's happening when we make an HTTPS request, because there's quite a bit involved. We talked about how HTTPS is really just HTTP, plain HTTP, but with this secure channel setup. And so I want to dig into this graphic, which kind of explains how that secure channel gets set up and all of the steps that take place before the HTTP part takes over. Okay. To do that, I'm probably just going to carefully try to zoom in. Okay. So in step one of the HTTPS initiation process, in step one, when the browser is requesting something from the server, so we've kind of, this visualization, we're ignoring the router, we're ignoring the ISP, we're just focusing on the two, the start and the end point here. So when the HTTPS process first initiates, we have to make sure that both the browser and the server can talk using the same protocols. And there's also a number of different cryptographic algorithms available, things like AES, RSA, if you've heard any of these terms thrown around. A lot smarter people than I came up with those things. And that very first step when you're launching this HTTPS connection is you and the server are agreeing on what you're going to communicate over. And that usually involves picking whatever the latest thing that both parties can support. So that's step one. How are we going to talk? How are we going to establish this secure channel? So the server then sends back, okay, you've told me what you can do. I'm going to look at what I can do, and then I'll tell you, okay, we've chosen this algorithm. The server also sends back a certificate, and that certificate is used by the browser for step three. So one of the ways we know that we're visiting google.com, one of the ways we know that we're visiting amazon.com, and like Shaw had mentioned, we're not visiting some other person impersonating google.com or impersonating Amazon, is that there's this notion of a certificate authority. When you download Chrome, when you download Firefox, when you download Safari, every single browser comes loaded with what are known as CAs, or certificate authorities. And these are known, good, verifiable, trusted authorities. And if we get a certificate from the server that hasn't been validated, hasn't been verified, hasn't been accredited by one of these certificate authorities, we know we're not visiting the website that we should. We know that someone's trying to impersonate. So when we make and we launch an HTTPS connection, we're not just trusting whatever certificate they're saying and sending back to us. We're also doing our own legwork in the browser. We're also verifying that the accreditation presented with that certificate comes from something that we know to be valid, or we know that we can trust. So that's step 3. The browser does its own independent forensics fact checking. Okay. In step 4, I had mentioned before that the HTTPS encryption involves this secret code that both parties know in order to send communication back and forth. Step 4 is the beginning of that, of communicating that secret code between both parties. So at this point, when we get to step 4, at this point, the browser knows that it knows what versions it's going to use to communicate over HTTPS. It has a certificate from the server saying it is who they claim to be. We've gone and verified that the certificate is valid. At this point, we can trust them and we can start sending data. The certificate that they present has instructions on how to send it data in an encrypted fashion. So on step 4, we're encrypting a secret code and we're sending it to the website, and we're saying, okay, I trust you. Here's a secret code that we can both use to encrypt our communications. And then we send that secret code using another layer of encryption that the certificate they gave us describes. And it kind of goes back and forth. So the server sends us, or we send the server a secret key. The server sends back the secret key, acknowledging that, yeah, it works. We're both going to use that same shared secret key. And then with 7 and 8, with step 7 and 8, this is where we're sending regular HTTP messages. So we've verified that the server is who they say they are. We have a secret code that we can communicate back and forth with. Again, you don't need to memorize any of this. This is just kind of a quick little diversion into what's happening when you go and load up HTTPS. Any questions?
Hey Nathan, this is Sean.
Yeah.
So when you have a session, whether it's your web or just browser, so when you, before I do that, so the first 3 steps are basically, I mean, lays the protocol or the arrangement for the message, for the exchange of data. So when you refresh a session, so what happens? Do you restart from step 1 or restart from step 4?
You know, I think that's more of a browser implementation detail, but I don't have an authoritative answer for you. But I do know that after you have initiated this process in the browser, haven't refreshed, but initiated this process, the browser is going to keep reusing that secret code for as long as that browser tab or that browser window is open. As far as when you close or refresh or something like that, I want to say that this actually runs again and recreates that shared secret key between the 2 parties. Don't quote me on it. I think it varies by browser, and I don't know enough about the internals to say positively or not. That is a good question, because this process is expensive. This process of exchanging data, doing all the encryption and decryption, it's a slow process compared to making an HTTP request and all of that. We have how many different requests going on here? We have one request going out, a response, another request going out, another response, and then finally we're on to HTTP. So that those extra calls add to our overhead. So for sure, this is one of those things that gets reused when you're visiting the page and loading other resources like images and all the other stuff, JavaScript, etc. Okay. There's actually a video that I found last night that's really good at describing how some of these secrets are encrypted. So I encourage all of you to check this out. It explains a bit more deeply how the encryption process works and how two completely different parties can securely exchange and get the same secret code. I'm not going to go into it, but if you have the time, please check it out. So we kind of talked a little bit about the pros and cons of just buying an SSL certificate. On one hand, it's real easy. Website, give them a couple extra bucks on Namecheap and they'll automatically provision one for you. Or like we did with Heroku, upgrade to, no, put your credit card in, I think was the only requirement. And you could link your custom domain and they'll generate one for you. So there's kind of pros and cons to it. You have the ease of access. You just give them money, they do the thing. The cons being, like we pointed out, you're not actually in control of the secret key. So you technically, there's a possibility that someone could decrypt your data for you, which could be a good thing, again, as a convenience feature for you as a developer, but it is what it is. If that makes you nervous, then more power to you. This is your section. I think that all the selling of TLS and SSL certificates is a scam. It's super easy nowadays to just generate your own. And the tooling for doing it is ridiculously easy. So if you take a look at this acme.sh or certbot, both of these are programs that will allow you to generate your own SSL certificate. So if you don't want to pop down the extra $10, $20, $30, take a look at either of these. And I promise it really is not a whole lot of work. All you really need to do is prove that you own the domain. That's the only thing you need to do. And either of these two websites will help you generate a certificate. One downside I will call out, though, is that these certificates by default only last for 90 days. Most of the certificates that you buy online last for up to a year. But with certbot, or rather Acme, most of the certificates only last for 90 days, which just means you need to put on your calendar, go refresh the certificate, which is like a 3-minute process once you have it set up. You can even fully automate it if you wanted to. For the paranoid people, for the folks that want to manage the keys directly and make sure that absolutely no one has access to decrypting the data except for themselves. But what do you need to know about all of this? What is the point of showing you all this? Well, it's mainly for your edification. As everyone knows, we have HTTPS set up on Heroku. It's pretty painless. You link it up with Namecheap, and then this whole deal in Heroku will generate an SSL certificate for your domain. So what really is the takeaway from what I've just spent, I don't know, an hour talking to you about? Use HTTPS on your website. It's really easy nowadays. Just use it. And if you have any questions about how to set up in Heroku, just let me know. Otherwise, I'm pretty sure everybody that has made a deploy with their front end is already using HTTPS. Yeah, so yeah, again, main takeaway here, use HTTPS for deployed websites. Now let's talk about HTTP for local. So when you run npm start, it's going to bind to localhost 3000, and then you would open that up with your browser, which would be HTTP. Should we use HTTPS for our local websites when we're doing local development? Does it matter? Shaw says no, we shouldn't use HTTP, we should use HTTPS. What do other people think?
Could it
Okay,
depend on the
Dominique's in.
situation?
Is-
Oh, okay.
Are there any alternatives? Like if you use HTTP, like is there something else that can probably make it more secure?
So is there something like quick and easy we could just tack on to give us some protection?
Yeah, I mean like maybe like there's a program or whatever where you get to somehow make HTTP more secure without encrypting.
Mhm. Yeah, that's a good thought. Let me back up though. When you're setting up HTTPS, when you're getting a certificate, whether it's given to you by Heroku, Namecheap, or you go to one of those websites I linked on the slide and generate your own, the certificate is attached to a domain name. So it's bound to a website, and it's used as proof that not only you own the website, but it's also used as the encryption for folks that are accessing your website to encrypt their data securely and send it privately to you, the website owner. Who owns localhost?
No one. I mean,
Is it a valid domain name?
I believe so.
When you go to localhost in the browser, where are you going?
To our localhost within.
You're going to your machine. You're never leaving your machine. You're never going on the internet. So can you generate an SSL certificate for localhost?
No.
The answer is you probably could. But then the next question is, who are you protecting? If your data is never leaving your computer, who are you encrypting it for? Who's going to come in and sneak in and steal your data?
Maybe you're using I don't know, like a local, like LAN or something.
Mm.
And
but if you're talking to your own machine, you'll never reach the router. No one will be able to see your traffic.
Yeah, I'm stumped. I don't know.
I want to make the sales pitch use HTTPS everywhere, but really for local development, it's just fine. That's the takeaway here. For local development, HTTP is just fine. With the caveat that if let's say you do an npm start, and that's going to bind to localhost 3000, HTTP localhost 3000. If your local npm create React app, if your local app reaches out to some service, let's say it's your Capstone backend, and you're using the deployed backend to talk to for your local development, it's not fine for your app to launch these outbound connections to other services and use HTTP. So if it's all contained on your computer and all you're doing is making network requests to your computer, that's where you got stuff like firewall on your computer to prevent folks from trying to get in. That's why we run antivirus software. That's why we try to make sure our development machines are safe. But for local development, HTTP is fine. Do not go through the trouble of trying to generate a certificate for localhost. Although if somebody can do that and show me that, I would be impressed. Because one of the things is when you generate a certificate, you got to get someone to accredit it. And I don't think the accreditors would issue you a certificate saying, yes, Kyle, you get a certificate. It's for localhost. You are the owner of all HTTPS for localhost.
Hey, Nathan.
Hey.
Yes, this is Shah. You got the point. I know it doesn't make a lot of sense to, even if you can, to use HTTPS. But so back to HTTP using that for local. So your backend, let's say your front end uses a local port like 3000 or something. So your machine assigns a port. So does that enjoy the same level of security like any other port? Like let's say your camera, or you had an external mouse or keyboard?
Well, external, like a mouse or a keyboard probably isn't going to bind to a port. It's going to bind through a socket. So it's going to get a Unix socket. Maybe I might be using the wrong terminology here, but it's going to be different. When we talk about ports, we're talking about network communication. When you plug in a mouse or you plug in a keyboard, that's more of a hardware level connection as opposed to a networking connection. Because like when you're using a mouse, you're not sending packets over the network card. You're talking to the kernel. You're talking to the operating system.
How about the wireless
right?
mouse? That's a different thing, maybe. Okay, that's fine.
Well, it's a good thing you're asking somebody that enjoys mechanical engineering, because with a wireless mouse, your USB dongle is terminating the 2.4 gigahertz radio signals going from your mouse to the dongle. So it still appears to be a physically connected device. So it's not going to use networking. But this is a good point to bring up, though, as far as ports. The way Mac works, by default, most ports are closed by the firewall. So other folks on your router can't reach your localhost 3000 on your computer, because all you're doing is binding to your machine. You're not binding to an address that others can reach. So localhost 3000, localhost anything really is pretty safe in terms of folks not being able to get in and also hit those endpoints from their machines. So your Mac comes with a firewall. It's pretty good by default. Okay. So that's HTTPS. Kind of long-winded, but I wanted to just show you all the moving parts inside of it. And the big takeaway here is use HTTPS. Except for local development, HTTP is fine. Okay, so that's HTTPS. Let's talk about DNS. DNS kind of suffers the same problem. So HTTP, when HTTP, the protocol was designed, it really wasn't intended to have a lot of security. That's why HTTPS came around, to kind of fill in some of the cracks that HTTP had, namely that folks can see everything if you don't apply encryption to HTTP. DNS is the same way. DNS is kind of one of those older systems that's been around for a long time, since the inception of the internet. And it wasn't really designed with the intention of being secure. So we're going to kind of look at how to secure that piece of the communication. And so far, we haven't really talked much about DNS, except for what we did last week, where we went and did this whole domain deal in Heroku. And if you'll recall, when we created when we added our domains in Heroku, it created a DNS target, which we then took back to Namecheap and we plugged into that box. So we were making a DNS record on Namecheap. So you guys have already kind of seen what DNS is. We haven't talked about it, so let's talk about it now. So you can think of DNS as a phone book, where you have all these different entries, and depending on what kind of website you're trying to visit, that name needs to boil down to an IP address. So every time you open up a browser and you go to google.com, your browser really doesn't know how to take you to google.com without DNS. Because what DNS does is it takes the name, it takes the phone book, and it looks up what the IP address associated with that name is. That's all DNS does. DNS actually runs before HTTP and HTTPS begins. So DNS happens when you make a network request. DNS happens, it resolves, it finds an IP address for whatever website you're trying to make a network request to. Then the HTTP, HTTPS portion starts. So think of DNS as just a big phone book. It's a way to resolve a human readable URL with an IP address. And you can actually go and look and see what your Mac is currently using for DNS servers. So these servers you can think of as those computers that hold on to the phone book, that tell you where to find the IP addresses of the website that you're trying to visit. Are folks familiar? I've thrown around the term IP address. Do folks understand that four-digit, or sorry, four number? So this. So that four number grouping that's separated by decimal points. You may have noticed that at your house, you get a IP address, and that IP address is given to you by your ISP. You also have a private IP address, which may be something like 192.168.1.1. Have folks seen that IP address before? Okay, so these, I'm not going to give you guys a whole spiel on IP addresses. I could, but in the interest of time, all this is this is a network address that we need to use in order to connect to a computer. So we can't actually make a network request to google.com without knowing the underlying network address of google.com. And once we have a number that looks like this, that's when HTTP takes over, and that's when we can send our normal HTTP requests. But IP addresses can come in all kinds of different flavors. So you can have, there's a bunch of rules that are associated with it, but for now, just think of IP addresses as being kind of a special number that can be used to find computers. Those DNS servers, though, those are the phone books. So we need servers that can tell us how to get to google.com, how to get the IP address of those servers so we can make network requests to them. So let's walk through an example. We've kind of got the same sort of diagram for HTTP, except I'm chopping off the server that you're actually going to visit, and you'll see why here in a second. So let's walk through when we're making a DNS request. So before HTTPS even starts, we begin with the DNS request. So we want to talk to google.com, and DNS is responsible for translating google.com into an address. So we start off and we say from our computer, either axios.get http google.com, or we load it in our browser or whatever. So we're asking, what is the address for google.com? How do we get there? How do we make a network connection? Your router probably doesn't know. Some high-end routers can cache DNS requests and also return them, so it can contain its own phone book. But let's pretend like we're just using a run-of-the-mill router. So your router probably doesn't have that phone book included. But your ISP, most ISPs will provide you with a DNS server unless you specifically set it to something else. So your ISP will have a DNS server or will point you to a DNS server. And that DNS server is going to say, okay, let me look at the phone book for google.com, find the entry. Okay, it's 172.217.14.206. And then that request is going to be sent back to you. At which point you're going to dial whatever that address is, and then you're going to start the HTTPS process, and that's going to invoke all the different parts that are associated with that. Now, let's talk about what happens if someone hijacks DNS. So let's say someone wants to send you to a website that isn't google.com. And let's say that they control your router. So this is kind of one of the easiest junctions to achieve this attack from. So if someone's able to get into your router, what they can do is they can overwrite the DNS settings. And if they overwrite the DNS settings, what they can do is they can insert their own phone book and say, no, Google.com isn't 172.217.14.206. It's actually 54.174, blah, 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 blah. So they can poison the phone book with their own entries, which effectively means that instead of visiting Google.com, you're going to go to wherever they send you. So whatever entry they want to put into that phone book. Okay. Any questions so far?
This is Latonia. This is kind of an odd question, but do people publish what their route is to try to counter something like this from happening? Like,
what do you mean by publish?
Like 172.217, is that their actual address for the DNS for Google? And then so if you got something and you need to check it, you can go there and check to see it's actually theirs. Does that make sense?
Yeah, it does. Yeah, it does. One of the ways that you can check to see if you're getting the wrong IP address returned. So if someone has poisoned that DNS cache, one of the things you can do is you can pop open a terminal, and there's a command that lets you make DNS requests in the terminal, and the command is called dig. So you could say dig and then the name of the website, google.com. This is what the raw DNS records look like for google.com. And you can see over here, this is the one thing that is the most important part of the answer returned by dig. This is the authoritative record. This is the answer to your DNS query. So this is the server that Google has, 142.250.69. You can use dig to look this up yourself. But let's say that whoever is operating my DNS, whether that be the router, whether that be the ISP, whoever's operating those DNS servers, let's say that they poisoned it. Now, if I did dig, it's going to return whatever entry that DNS has for google.com. So if someone poisons google.com, dig is still going to return the bad entry. But what you can do with dig is you can make DNS requests to a known good DNS server. And there's a couple of these on the internet. So 1.1.1.1 is Cloudflare's public DNS. 8.8.8.8, that's Google's public DNS. I think 8.4.4 is another one of their public DNS. So if you wanted to cross-check with a known good server, a known good DNS server, this is how you would do it. So you'd use dig, the @ to specify, I don't want to rely on what my computer is saying this DNS result is. I'm going to go check with a known good DNS source. That's where you would use the @ to specify that. Now, it just so happens that these two numbers are different. And the only reason why is because Google has a bunch of servers that they use for google.com. So we will get a different IP address every time we dig. So just in case somebody was going to ask that question, the reason why is because they do load balancing. So they'll offer different DNS records as a way of breaking up the load across all their different servers. Okay. And we can actually look at, so I have a website called Django Best Practices. And if I look at that, it's hosted on Heroku. Django Best Practices, did I spell that right? No, okay. Well, let's just do a query on Amazon.com. So here we can see this DNS result actually gives us 3 different IPs that we can choose from. So some websites will offer up one DNS result and they'll change the IP as a means of load balancing. Other places like Amazon, their phone book, their DNS server will return multiple and let you pick which one of the servers you want to visit. Now, all this is handled underneath the hood. You never have to manually interact with some of these things, but anyways, that's how you would cross-check if you really suspected that you were getting bad DNS results. Other questions? This is just a free tidbit, but one of the most popular ways to block ads is through DNS. So if you've ever heard of Pi-hole, there's a popular program that you can run on a Raspberry Pi if you're looking for a way to get into Raspberry Pis. There's a popular program called Pi-hole, and it acts like a DNS server. And whenever it detects that you're loading content from a website that serves ads, or ads are about to be injected into the browser, it blocks it at the DNS level. So your browser never makes a request to load advertisements in the browser. It's really cool. But you could run your own DNS server as a way of also, if you've got kids, you can block content by running your own DNS server. So DNS is pretty useful. But it has a flaw. Again, it's not encrypted. It's kind of an older system. But just to set perspective here, I would really consider securing DNS to be much, much lower in terms of priority to HTTPS. So if you're debating which of these two things you should ensure is implemented for your Capstone, definitely focus on HTTPS first. The DNS is definitely secondary. And I also want to call out, I think Shah had brought this up before. So let's pretend like someone poisons the DNS cache, and they're trying to redirect you from google.com, the good google.com, to some hacker's google.com. Well, HTTPS still throws a wrench into that, because the SSL certificate that's issued to google.com also ties it to a certain set of IP addresses. And so even if you were able to poison the cache, you wouldn't be able to provide the same certificate as google.com. Even though that certificate is public and anyone can see google.com's HTTPS certificate, it's still encrypted in such a way that only Google can decrypt information from that certificate. So if you poison the cache, if you decide, okay, today I listened to Nathan, I'm going to be a hacker and I'm going to go poison some DNS caches for google.com or Amazon, you're still kind of out of luck, because HTTPS throws a major wrench in that. Now, what they can do is they can provide their own certificate, but it's going to pop up some weird UI in the browser. You probably have all seen this, where you get a website that has a certificate that doesn't really work right, and so you have to go and click advanced and view site anyways. That would be the kind of scenario that you would find yourself forced into if you decide this is the career, poisoning DNS caches is the career you want to go into. Poisoning DNS caches works great for websites that have HTTP. So that puts HTTPS way up here on the priority list, as opposed to what I'm about to talk about, which is securing DNS. So if HTTPS is really just HTTP with encryption built on, well, guess what? We got DNS with encryption built on it too. And it's called DNSSEC. So it's the same sort of thing as we had just walked through. So let's pretend like someone's poisoning the cache on our router, or poisoning the cache on the ISP's DNS servers, or somebody gets in there and starts doing monkey business. We'll get to this point where we get one of those poisoned entries from the DNS cache. But what will be different about it is that we will say, no, prove that the address is really what you're saying it is. And this really has the same sort of mechanisms under the hood as HTTPS, where DNS has a certificate. So for each of the DNS records, or rather for the domain that you're providing DNS on, it will also include a signature that you can verify. And of course, this will make the hacker very angry, because he can't prove that that actually belongs to that address. All right, so let's talk about how you can actually actually apply this in practice. So it's probably going to be really underwhelming, but you go to Namecheap, you log in, and under Advanced DNS, you toggle a box at the end. No, it really is that easy. The only difficult part is being patient because it does take a while for the DNSSEC entries to get generated, but that is it. So I'm going to actually take a minute for folks to just do this right now. If you go to namecheap.com, I'd like you all to go into your domain and then to the advanced page. And just flip that DNSSEC box on.
Okay, Nathan, I apologize. Can you say the steps again?
Sure. Are you logged in Namecheap?
Yep, I'm in Namecheap.
Did you click manage on your domain? Did you click on advanced DNS tab? Okay, scroll down until you see the word DNSSEC. Flip that on. Yep. It's interesting that Namecheap just makes it this easy. I kind of wish they would do the same thing for HTTPS and trying to upsell you on because behind the scenes we're doing almost all the same work that would be involved for generating an HTTPS or sorry a TLS certificate. Including all the accreditation. It's kind of a paying for TLS is highway robbery. Okay. Folks can continue doing that. I'm just going to jump to kind of an informative slide really quick. This is how you can verify that DNSSEC has been applied to your domain. And it's kind of hard to know whether it's been applied successfully because if it hasn't been applied successfully, DNS will still take over. You'll still be able to reach whatever your domain is. So to actually know whether or not DNSSEC has been applied, to know if you've mitigated that DNS cache poisoning issue, there's a command in the terminal that you can run. So let me close a couple windows. And it uses our command dig. When you think DNS, think dig in the terminal. Okay, so we will say dig and grab our website. And then there's a special command that you will pass to dig. It's a plus DNSSEC. I don't know why they chose to use plus for an argument as opposed to what we've all kind of seen where they use dashes, but for some reason they decided to use a plus. Okay. And if you hit that, you should see something that looks like this. This is a special record type that's generated when you enable DNSSEC. And this is the actual signature that's being used to verify that this DNS entry is controlled and pointing to the correct server. Okay. I'm going to use Cloudflare's DNS. But you should also see a flag up here for AD. So you're looking for two things. You're looking for this RRSig DNS record and this AD flag. If you've just enabled it and you run this command on your computer to check your domain, like I said, give it a little while because it takes some time for the record to resolve. Okay.
So Nathan, your slide says at 1.1.1, but you didn't just do that. You just said the dig and then the website. Does it matter?
For me, it does because I run my own DNS server. And I think my DNS server is malfunctioning because it's not showing me the AD flag. I think it's just not set up to use DNSSEC. For you, you could probably run it without the at 1.1.1 because you're probably not running anything crazy in your house. But this is kind of the safe way to check this because you're using a known good DNS provider. But actually, that is what it is. I don't have DNSSEC enabled on my DNS server. That totally makes sense. You guys probably won't need to add the at 1.1. But I think it will take somewhere like a couple hours. So feel free to come back and check that. Okay. So this is where I want to stop for today. The next thing that we're going to talk about tomorrow is how to do authentication. So for folks that are interested in usernames and passwords and logging into the website, definitely be here tomorrow. But I think this is as much as we're going to cover for tonight. So if anybody has any questions about some of this HTTPS and DNS that we covered tonight, feel free to ask them. Otherwise, I think I'm actually going to give you quite a bit of time back today. We kind of need to get this foundation out of the way before we can jump on to some of the more advanced stuff with authentication and authorization. So if you have any questions, feel free to ask.
Hey Nathan, this is Shah.
Hey Shah.
So my IP address is always the same whenever I try it. So it's public IP address. So I mean, if you get private IP address, then do you need to do anything else if you were to deploying something? Or no?
Yeah, I mean, if you're deploying something, you're not. So private address just means it's an IP address that's
dedicated to you.
Dedicated to you by the router.
Oh,
It doesn't exist on the internet. So no one on the internet can reach you at that private IP address. It's only between you, your computer, and the router.
Okay. Thank you.
Any other questions about HTTPS or DNSSEC? Folks think that they've got a pretty good handle on this. I mean, it's technology. I mean, probably the only thing that you've seen that's new tonight is probably DNSSEC because it's an old technology, but it's sort of resurged in popularity. Everybody's been using HTTPS. It's part of the modern web today as we know it. Okay, so let's talk about homework then. So the homework for tonight is going to be pretty easy. So I want everyone that has a domain name to have DNSSEC enabled. And for that, I'm going to check using dig command just to make sure that you all have it turned on. So when you send in the homework, I will make sure that there's a instruction for you to also send me whatever it is that you're using for your capstone for your domain name. So I want you to send me that domain name so I can double check it. And then I want everyone to ensure that inside of their capstone, they're using HTTPS wherever possible. Now, I don't expect you to zip up your capstone and send that to me. What I'd rather you do is use Git to push up all of your code and make sure that your most recent front end and back end are pushed to GitHub, and send me links to your GitHub repo so I can look at the code and make sure you're using HTTPS throughout. Do those instructions make sense? Is everyone at this point feeling comfortable enough with Git to use that as a mechanism for sending me the homework?
I don't have a domain. My capstone isn't tied to a domain name yet.
Okay.
So
are you using Heroku?
Yes.
Okay. If you don't have a domain name, don't worry about the DNSSEC part. Just make sure that your app is using HTTPS internally. Okay. So all of your Axios, all of your fetch, all of your navigation using HTTPS, and make sure you commit and push that up and send me the link to your GitHub repo. Does that make sense?
Yes.
Cool. Any other questions?
Nathan, when you say make sure we're using HTTP, to just update them.
Sorry, I think you cut out for a second. What'd you say?
I'm sorry. I'm just asking if we're literally just going through and adding an S to our URL if we don't happen to already have them.
Yes, it can be that easy. But you also need to think about what you're going to do for localhost when you're not using HTTPS. So when you run npm start, if your app talks to itself and it redirects to itself on different pages, you may not want to use HTTPS because you don't run HTTPS locally. So you'll kind of need to think carefully about how you're going to use HTTPS when you're deployed and HTTP when you're running locally. Does that make sense? And if you don't have any network requests, if all you're doing is static HTML and a very lightweight bit of JavaScript, then good for you. The homework's already done. No network calls to replace with HTTPS. But I guess I would suggest when you're looking through your capstone, do a search for fetch, do a search for Axios. Wherever you're doing those sorts of things, make sure that if you are using HTTP, switch over to HTTPS. Okay. Any other questions? Otherwise, we can go ahead and end early and I can give you guys the time back. All right. So tomorrow we're going to talk about authentication. So I'd like folks to have their capstones in a pretty good working order because I'm going to have a lot of code to throw your way, especially for the folks that want to do this and incorporate it into their capstone that actually are taking in username and password. So that's what we're going to be doing tomorrow. Otherwise, have a great rest of your evening, and I will see you all tomorrow for authentication. All right. Have a great rest of your night.